I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 1st.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, yes, we have a gale pushing over the North Dateline region with about 36-foot seas aimed off to the east. Seas were actually higher yesterday, and this system is supposed to continue off to the east with some amount of size, likely resulting in swell for both Hawaii and the U.S. West Coast. And down south, there's activity going on as well. Let's get into the details, but let's start up north. As usual, we'll start by looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, a dip in the jet, just like there, and maybe almost like there. That helps create a counterclockwise flow aloft and also down at the ocean surface. And counterclockwise flow in the northern hemisphere is the hallmark of low pressure. Low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and create seas. Seas, if they're high enough, as they radiate away from the fetch area, turn into swell. And of course, swell, when it hits your beach, turns into surf. So we have some potential targets here. One off the U.S. West Coast, one over the dateline that we know is supporting a gale right now. Maybe another trying to develop over North Japan. So we get into Monday. The one off the U.S. West Coast pushes onshore. The other one moves into the northern Gulf, and the one in the west kind of flattens out. Winds are still pretty decent speed, though, 150 knots, feeding into a fairly broad trough that's supposed to set up in the Gulf on Tuesday, and actually building to nearly 170 knots. That certainly should support gale development of some kind. Then it kind of flattens out. Notice the jet starts splitting on Thursday night over the far west Pacific. That's not a good sign. The split jet stream, like one flow there, creates high pressure in between, does nothing for swell production. So we get into Friday, a little bit of a trough here in the western Gulf and some sort of a persistent low pressure pattern pushing into the U.S. West Coast. Then the jet starts ridging. That also supports high pressure underneath it. It sort of looks like the end of winter as we get into next Sunday. We're 180 hours out. The jet very weak over the West Pacific and split, and the last little bit of decent energy is inland over the U.S. mainland, doing nothing for gale production. Next up, surface level pressure, surface level winds. As we know, there is some sort of a gale over in the North Dateline region. Here it is. Low pressure, circulating counterclockwise with 30, 35, 40 knot winds out of the west, targeting primarily the U.S. West Coast, but side and band energy down into Hawaii. So we get into Monday. That gale quickly pushes off to the east. Another little system tries to organize off Japan, really doesn't make it. Tuesday, the remnants of the initial gale fade in the northern Gulf, winds off the U.S. West Coast. And then things kind of fall apart. Another little gale here is forecast with 40-knot winds. You notice much smaller in coverage, but targeting Hawaii. Maybe something will result from that, but then that too fades off as we're into Friday. Pretty much nothing happens. High pressure there, high pressure 1032 millibars off Japan, doing nothing for swell production. Another little gale forecast, theoretically Saturday night, but lifting north very fast, maybe getting a little bit of traction on the ocean surface. And it too fades out. The high pressure machine in full gear, 1036 millibars off the California coast, producing 30-knot north winds, and 1036 millibars west of the dateline, doing nothing for swell production. All right, let's go take a look down at the surface, the effect of those winds on the ocean surface. Now, we're actually going back in time to Thursday, a couple days ago. Small little primer gale developed off of, well, there's Kamchatka, there's the Kuril Islands. Little area, 26-foot seas right here, 26.8 feet. The highest seas over this entire domain. They pushed off of Kamchatka into Friday, slowly started fading, seas down from 25 feet, and that was nothing. Tiny little swell has been produced by that, bound for Hawaii and the U.S. West Coast. I think Hawaii, it's the early part of the work week. California, maybe mid-work week. But the stronger system started developing off Japan on Saturday. This was a day ago, with seas quickly building to 39 feet, and then 40 feet Saturday evening, not even at the dateline yet, and then continued over, approaching the dateline as we got to right now. There's the dateline. It's at the dateline, 35-foot seas aimed off to the east. Let's look forward. Now that data was hindcast data, the 00 hour version from the model. The most current data, what is presumed to be exactly what's happening right now, and that past animation was every 6 hours the hindcast image from every run of the model stacked up. But now this is all forecast data looking forward. So as we get into Monday night, seas start fading as the gale pushes over the dateline with 29, 30-foot seas. Then by Monday, down to about 26 feet in the northwestern Gulf. And by Tuesday morning, seas down to 23 feet, 23.6 feet, and fading from there. Certainly energy bound for the Pacific Northwest down into northern and central California. Not sure how much will make it into southern California. And certainly you can see the swell front right about here, bound for Hawaii on, well, let's say about Wednesday, something like that. Maybe Tuesday. I think it's in early. Oh, the first swell's in early. And that Wednesday, the main part of the energy moves into Hawaii. Looking out, we know there's another little gale forecast, but you can see really seas never even barely reach 20 feet, and that's all of about that. Now, as we get further out into the model, this is on Sunday. We're almost a week out. Theoretically, 22, 23-foot seas are forecast here in the northern Gulf, but that's a week out. Don't know that we really believe it, but if it would happen, that would probably be the very last hope for anything this winter for the North Pacific. That said, and not to be outdone, the South Pacific has been productive. Again, 00 hour hindcast is a stack of models. We're going back almost a week ago, Sunday a week ago. Gale developed under New Zealand with 31-foot seas, building to about 32 feet, 33 feet, and then a second pulse of it wrapped up again, producing 37-foot seas to 39 feet, all aimed well to the north. That swell is in the water, hitting Tahiti as we speak, bound for Hawaii and the U.S. West Coast. That one faded, but then a secondary gale built right behind it on Wednesday and started lifting north with like 33, 34-foot seas. And then it pushed across the South Pacific into about Friday and then started fading out. And as of right now, where are we? We got one more little bit to go. Here we go. Little gale developed under New Zealand, but it's falling southeast. Nothing named north, nothing expected from it. Let's go look at the future. Now we're into the forecast model. That system in the deep South Pacific continues like basically falling southeast. The gales need, in the southern hemi, they need to be pushing up to the north to get swell. Whichever way the gale travels, that's where all the swell energy goes. If the gale's falling southeast, well, there's Antarctica. That's where all the swell goes. Also notice that the ice shelf here, the Ross Ice Shelf and other ice shelves along here, very far to the south. It's very early in the winter down in the southern hemi, so ice has not really started to build up. This is a great time because the distance between New Zealand and the ice shelf is expanded. Storms, even if they're well to the south, get traction on ice-free waters and can produce surf. But later, as we get into the July time frame, even August, the ice line will go up to about 62 south, something like that, like all over in here. And all this water will be covered with ice down there, and you cannot generate swell no matter how much wind you have if it's blowing across, 8 feet of ice. So anyway, looking out, Wednesday, Thursday, just not a whole lot going on. This gale right here, forecast on Friday, it had shown stronger in earlier runs of the model. Now it's down with, 26-foot seas, something like that. Probably good for maybe some 14, 15-second period swell at best. Theoretically, another gale under New Zealand a week out, but we don't believe that for a second. All right, wind swell production. Springtime, La Nina, lots of high pressure. There it is, 1028 millibars. Winds circulate clockwise around the high pressure. You can see it as they start bumping up against Cape Mendocino. Produces north winds, 20, 25 knots. That's pretty much what's going on over at the coast right now. And into Hawaii, trades, 20 knots, pretty strong and in control. So we get into Monday, Little low pressure pushes inland. High pressure will surge right behind that. You'll get, there you go, 25, 30 knot northwest winds along the coast. Trades continuing 20 knots over the Hawaiian Islands. Good for easterly wind swell there. Good for northerly wind swell along the California coast, but pretty raw. Tuesday, same sort of deal. Northwest winds, 20 and 25 knots. Trades, 15 knots, maybe 20, a little bit less for Hawaii. As we get into Thursday, finally a little bit of a break as low pressure sets up in the Gulf of Alaska. Probably won't last too long though. No wind swell for California. Trades 15 plus knots for Hawaii. Friday, same sort of deal. Lighter pattern, low pressure pushing into the Pacific Northwest on Friday, and you can see on Saturday, here comes the high pressure setting up strong and bold in the Gulf of Alaska, and the northwest winds by Saturday afternoon, nuking along the California coast. Not so bad for Hawaii. The axis of the high pressure pretty well east of Hawaii, maybe giving them a little bit of a break, but California, more upwelling, more north winds, cold water temperatures. Point Reyes buoy right now, 49 degrees. Others along in the San Francisco area in the 50 to 51 degree range. So not horrible, but certainly not warm. Bring your 5 mil suit. Precipitation for California. California right there. We'll run through this. The short answer is, if you're in Cape Mendocino, yeah, a little bit pushing through on Monday, maybe another little pulse here on, there you go, on Thursday evening. But Tahoe, no snow of any magnitude, and San Francisco, high and dry. Get into Saturday. Oh, there we go. Actually, a couple little flurries forecast for maybe the Tahoe region Saturday night. Let's go back and look at that. Yep, Saturday night, and maybe almost into Sunday morning, falling down the crest of the Sierra, but pretty weak, and then high pressure locking in control. Snow forecast dashboard for Olympic Valley, Squaw Valley, maybe an inch if you're lucky. And we'll see what happens. That's still almost a week out, so odds are that won't materialize. Snow levels, freezing level about 12,000 feet, dipping theoretically there on the 8th down to maybe 3,000 feet for 6 hours or something like that, and then right back to 12,000 feet. It's that time of year. Things warming up, late spring. I mean, we are into May now. Not surprising to not see any more snow. Though, officially speaking, Olympic Valley is saying now they're going to be open till the end of May, till Memorial Day. We'll see how much terrain stays open. Down low, probably not so much, but they'll be uploading. You can ski up top, late season skiing, not so bad. Take what you can get while you can get it. There was 84 inches of snow over that, about a 1 week window. Was that 2 weeks ago, something like that? So, yeah, a little bit of fresh to keep it going and to keep the water tables decent. All right, let's go take a look. Long term, what's going on with the Madden Julian Oscillation? That drives our weather out maybe a month. Maybe you can get even a 2-month look at it. And then El Nino, Southern Oscillation, currently in La Nina. But that might give us a look out maybe 9, 10 months, maybe even a year. Let's dive in. So first off, we'll start the MJO discussion. Madden Julian Oscillation. This periodic weather oscillation rotates around the planet from west to east. There's an active phase and an inactive phase. The active phase on one side of the planet, inactive phase on the other. They rotate around the planet from west to east. When the active phase is effectively a low pressure system, inactive phase a high pressure system. When the active phase pushes over the Pacific, feeds energy to the jet stream, helps feed storm development both in the northern hemi and the southern hemi. Also can reverse or lighten trade winds wherever the active phase is on the equator. And what that does then is can create a Kelvin wave. Warm water that's typically in the West Pacific can push it off to the east. Successive active phases of the MJO can create successive Kelvin waves, which end up shifting the balance of warm water in the Pacific from the West Pacific to the East Pacific, and that can help usher in El Nino. So we're very interested in two reasons for the active phase of the MJO. It feeds energy to the jet stream, and it can also create Kelvin waves. The inactive phase of the MJO we don't like at all because that steals energy from the jet stream, and all it does is it creates high pressure over the Pacific and feeds enhanced trade winds and sort of squashes low pressure development. All right, so This is data from the TAO buoy array, series of buoys strung across the equator in the Pacific. This is the West Pacific here and the East Pacific here. It's used for monitoring El Nino, but we can also get some clues on what's going on with the MJO. We're just looking at the arrows. The arrows are wind speed and direction. The longer the arrow, the stronger the winds. You can see pretty strong east winds in the East Pacific, pretty strong east winds in the Central Pacific, pretty strong east winds over in the Kelvin wave generation area, the West Pacific, from 135 east. The date line's right there at 170. That's the equator there. It's only this area 5 degrees north and south of the equator, from the far West Pacific out to about 170 west. We call it the Kelvin wave generation area. That's where all the magic happens when the active phase of the MJO pushes over the Pacific. Right now, we don't see an immediate sign of it, but this is just wind speeds. We want to look at historically, are these winds stronger or lighter than normal for this time of year? All right, so you look at anomalies, the difference compared to normal for this time of the year. See, well, the winds may be a little bit stronger out of the east in the East Pacific, definitely stronger, modest to moderately stronger in the Central Pacific, about the same thing in the Kelvin wave generation area. This smells very much then of the inactive phase of the MJO. So let's go look at the wind forecast. This isn't actual winds, it's the wind anomalies, the difference from normal compared to this time for this time of the year. And it's just the east-west component of the wind we're looking at. This is the whole planet, all right? The date line is right there, so that's close to the Kelvin wave generation area. The far West Pacific starts about 135 east, so right about there. And the Kelvin wave generation area ends at 170 east. So really, it's just this area right here we're interested. Or you can go the whole way up the chart. This is past history. The blues, easterly anomalies. Consider that the inactive phase of the MJO. The reds, western anomalies, the active phase of the MJO. So you can see back in April, early April, there were westerly anomalies. Pretty strong. Looks like the active phase of the MJO. Then it kind of faded out. You get this easterly wind burst that happened later part of April. Here we are today, a little bit of westerly winds. You go, well, maybe. But then you see, well, the current bulk of westerly anomalies for the next week are forecast deep in the Indian Ocean. And you see easterly anomalies again about 4 or 5 days out trying to take over the Kelvin wave generation area. So it certainly looks like the inactive phase of the MJO in the Pacific for now, with the active phase over the maritime continent, if not the Indian Ocean. Let's look further out. All right, outgoing long wave radiation, OLR forecast, another word for cloud cover. The active phase of the MJO is a low pressure system. Clouds typically are associated with a low pressure system. The inactive phase typically associated with high pressure, no clouds, dry air. Right? The blues means more clouds than normal. The yellows, if they were on here, mean less clouds. So the blues are the active phase of the MJO. So this is, oh, and let's get oriented here. The equator right there. South America, Central America, Hawaii, New Guinea there. Kelvin wave generation area right about there. West Pacific on the equator. Maybe the weakest of weak types of active phase of the MJO. 5 days out, fading, gone 10 days from now, trying to make its way back 2 weeks from now, 15 days from now. This is the statistic model. The dynamic model suggests, well, no, maybe the inactive phase showing up 2 weeks from now, but fading out. So kind of a mixed bag, probably no MJO signal at all. And whatever active signal there is, at least the only model that really shows it is this dynamic model here. It has it over the maritime continent 2 weeks from now. So probably not a whole lot of support jet stream-wise for gale development for the next 2 weeks. Let's keep going. Phase diagrams, another way to look at the MJO. Statistic model here, dynamic model here. MJO moves west-east from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. So this red line here is where it's been in the 17th, 18th, 19th of April. Here we are today, the heavy dot, that's where the active phase is. The further the active phase is out here away from the circle, the stronger it is. So a very weak active phase over the maritime continent today. The forecast, you can't even see it. It's just all balled up. The statistical model says the active phase just basically staying exactly where it is for the next 2 weeks. The dynamic model suggests, no, it's going to somehow magically retrograde back to the Indian Ocean and start pushing its way through the Indian Ocean 2 weeks from now, but all inside the circle and incredibly weak. So in either case, real no support for the jet stream or gale development. The upper level model, this is from the 25th of April, so it's a little bit stale, but just eyeballing it, we're not even going to get into the details because it's almost a week old, but just the general sense looking at no clear-cut pattern. Yes, some sort of a weak active pattern going across the North Pacific. The greens, areas favorable for precipitation, going across the Pacific in the early part of May, and then just kind of a mixed weak pattern after that. So then we go to the CFS model. It's a dynamic model. Again, the east-west component of the wind, the blues, easterly anomalies, the reds, westerly anomalies. Kelvin wave generation area starts about 135 east right here and goes to 170 west, so right in that box there. But you look up here again, you can see, well, what's this solid black contour? That is the MJO, the active phase of the MJO. The dotted contour is the inactive phase. So the active phase happened in early April, but we kind of already saw that from the other chart. We're in some sort of a weak inactive phase, and then looking out, you see no black dotted line of any sort in the Kelvin wave generation area. We see the active phase trying to set up in the Indian Ocean, maybe moving to the maritime continent, but not making it into the Pacific. As a result, with a La Nina base state, you get these blues, these easterly anomalies. They're supposed to set up about a week from now, hold pretty strong, fade for a week, and then redevelop again. So just no clear-cut MJO signal. Let's keep going. The CFS model going out 3 months. All right. Now this is different. What has happened is down below. The forecast is up above. You can see back in January there was a westerly Kelvin wave generation area roughly 135 east to out 170 west. So that box right there. And you see pretty good Kelvin wave back in January, westerly wind burst, and we got a Kelvin wave from it. Then easterly anomalies took over. They continue taking over, and then theoretically one more little pocket here in like mid-May. Then notice the pattern is steadily shifting off to the east as westerly anomalies, which were locked up outside of the Kelvin wave generation area, little bit at a time, start slowly encroaching more into the Kelvin wave generation area. This line right there, just go down, it's about 170 east. So by the end of the model run, basically the whole Kelvin wave generation area is supposed to be full of westerly anomalies. That looks pretty good. Let's overlay the MJO signal. And as expected, well, here's our very, very weak inactive MJO that's over the Kelvin wave generation area right now. Forecast to hold. And you see it just sort of continuing, and maybe some sort of a weak active phase way out in June or July, but really just a weak pattern. That's pretty typical of La Nina. But again, you get this sense that everything's shifting off to the east. Let's overlay the low-pass filter. Maybe that'll give us a clue as what's going on. And sure enough, look at this. See, it's not super obvious, but there's this line, this solid line here, pushing off to the east. The dotted line pushing off to the east as well over time. All right, the dotted line here, this is the low-pass filter. Low pressure, high pressure bias. The dotted contour is a high pressure bias. Consider this the La Nina indicator was locked right over the date line this past winter, January. Slowly easing off. Now it's about 150 west, so somewhere south of Hawaii. Maybe even moving beyond that as we get a couple of months out. And the low pressure bias, the El Nino indicator, which was over the maritime continent pretty much all winter. The leading edge of it is now in the Kelvin wave generation area at about halfway through it, almost 150 west, and forecast to slowly just inch its way further to the west to about 170 east, so almost filling the Kelvin wave generation area as we get into July with two contours. I mean, this is probably two contours of the same thing setting up. Yesterday, the high pressure bias, which has two contours too, totally stubbed off around somewhere in July. Today, looks like it's going to try to linger on, but you get the sense the high pressure bias is trying to get weaker, trying to move off to the east. The low pressure bias is trying to build stronger and push off to the east into the Kelvin wave generation area. But the models have been suggesting this for months. And let's look at this line right here. Whoops, and I can't really draw it with my mouse, but it's been almost stationary from January into about somewhere here at the end of March. And then little bit at a time, it's starting to creep off to the east, maybe like a degree or two a month or something like that. But any eastward movement is good. That pattern is supposed to continue, but the question is, where will we be as we get into October and November? And will the low pressure bias be far enough into the Pacific to actually feed decent active phases of the MJO, feed energy to the jet stream, and get us back to a semi-normal pattern? That is the million-dollar question. Let's go start looking for clues about El Nino and La Nina down in the ocean. Sea temperatures at depth. The balance of where the warm and the cold water is. That's what we're looking at here. West Pacific here, East Pacific here. These little X's. Sensors on the TAO buoys. These are the anchor lines. The X's are sensors on the anchor lines. They're all looking pretty healthy. We've got pretty good data. This data is collected at least daily, sent to a central processing facility, use a model to fill in the gaps. You have the 29 degree isotherm, that's 29 degree centigrade, in the far west Pacific, steady about where it was last week. The 28 degree isotherm, I think it's steady too, about 174 east, something like that. The 26 degree isotherm is at 140 west. I think a week or two ago it was at 120 west, so it's backtracking a little bit. But the 24 degree isotherm, pretty much steady across the Pacific. This is the equatorial Pacific, just 2 degrees north and south of the equator, the whole way across the equator. But it's not the temperatures, these are the means, it's the anomalies, you guessed it, anomalies, differences from normal for this time of year. Now this model suggests, and the data suggests, well, we've got lots of warm water here in the far west Pacific, no big surprise, driven by trades that have been nuking out of the east. We need an active phase of the MJO to push over here, but to start taking this warm water, it doesn't push on the surface, it goes under the ocean, and just like that. I mean, this looks like a Kelvin wave working its way off to the east, okay? And a little bit of cold water here. This is one model depiction of it. Then there's this other model. Still, it's showing the same warm water moving to about 145 west. I think last week we were at 155 west. So this looks like a Kelvin wave that's in flight. It was driven by westerly anomalies not too long ago. Let's look. Yes, this weak active phase of the MJO that had decent westerly winds that didn't even make it to the dateline back in April have created what appears to be a Kelvin wave. And here is that Kelvin wave, again, making it to about 145 west. We expect it to continue off to the east, slowly cutting off these cool waters, which were much stronger 2 or 3 weeks ago. They're collapsing, remnants of the last Kelvin wave fading here off of Ecuador. So there is some hope in the models. Not a super strong pattern, no real clear hope for another active phase of the MJO, but at least we have a Kelvin wave in flight. It'll take about 2 months to make it across the Pacific, but that should at least help hold La Nina at bay. Sea level anomalies. So this is not temperature data. This is the height of the ocean, right? You use satellite, determine the height of the sphere of the ocean. Is it higher or lower than normal? Take the waves out, the wind waves out, the tide, and, well, let's get oriented here. Chile, South America, Peru, Central America, Baja, Hawaii right there, equator there, dateline there, New Guinea there. You see higher than normal anomalies. Higher sea heights mean warm water at depth expands. When it expands, creates a bump on the ocean surface, and that in turn can be picked up by the satellite, suggesting warm water at depth. And look at this, it's actually encroaching to, what is that, about 160 west, maybe even to about 145 west. That's what we saw in the other chart. The other thing is that this little finger of warm water has been holding steady, slowly working its way across the Pacific, and there was a negative anomaly. So cold water, likewise, contracts, creates a divot on the ocean surface. There was a 15 degree or 15 centimeter negative anomaly right here a couple of weeks ago. That's all evaporated. And this was 15 centimeters over a much broader area off of Peru even a couple of days ago. That's in retreat. So we suspect a Kelvin wave is working its way off to the east, and maybe some of this cold upwelling that's going on here is in its final phase. Upper ocean heat anomalies, a nice way of just putting it all together. Time over here would go back almost a year. The West Pacific here, East Pacific here. Kelvin wave last May, another Kelvin wave, you can barely see it here, last June. And then we got into this cold upwelling phase with 1, 2, 3 upwelling events. That's the hallmark of La Nina. And then back in January, remember we said there was a Kelvin wave driven by the active phase of the MJO. So look at all the warm water here in the West Pacific. The active phase moves over here. Actually, it'd probably rotate more that way. Driving westerly winds, taking this warm water, putting it in motion. You see Kelvin wave made it the whole way across the Pacific, faded about the beginning of April. We had another active phase of the MJO early in April, and there you can see our next Kelvin wave, or what we think is a Kelvin wave. It certainly is making it further than anything that hasn't been a Kelvin wave in quite a while. So we suspect another weak Kelvin wave is on the way. Still, it'll take about 2 months to make it across the Pacific. But the more warm water you get on the equator, the better the odds for trying to cut the legs out of La Nina. Sea surface temperature anomalies. Now, this is a different story, okay? This is differences from normal for this time of year. South America, Central America, Hawaii right there, the equator right here. Kind of a fragmented picture, but yet you get the general idea. The blues, colder than normal temperatures. Much colder off of Peru, upwelling going on here, okay? And then the trades, high pressure in the northern hemisphere, high pressure in the southern hemisphere, rotating that way, tap that cold water, drag it across the equator. And that, in turn, feeds more high pressure because cold water does not support evaporation. You get high pressure over cold water, and that just continues the whole La Nina cycle. So right now, if anything, it looks like La Nina is being reinforced. These temperatures were warming up after the last Kelvin wave, but now with this cycle of upwelling and high pressure, things not looking particularly good. Sea surface temperature trend for the past 7 days, real simple. Blues, temperatures getting cooler. Reds, temperatures getting warmer. You can see it here, South America, Central America, Hawaii, the equator right there, New Guinea there. Cool pockets of cooling, with one pocket of warming right off of Ecuador. But the cooling, this is again part of that upwelling cycle that we've been seeing. We think trades are actually blowing pretty hard here too, so it's a double whammy. You have stronger than normal trades, that creates mixing, that creates upwelling, and then you have an actual upwelling event driven by, typically when you have the Kelvin wave erupt, then after that you get a bit of an upwelling event. So it's a downwelling, upwelling type cycle. So the remnants of that upwelling cold cycle still evident today. And then the backed off view, saying what we, the same picture. Blue, colder than normal temperatures off of Peru, making it up that there's warmer temperatures off of Ecuador, but you can see just the massive expanse of cooler than normal water supporting high pressure. You also get this high pressure building over Hawaii in the springtime. You see the upwelling along California. This happened last year as well. And we'll see how strong it gets, but there's some atmospheric singles that suggest that this will develop to temperatures pretty cold off of California right now. Sea surface temperature trend in the Nino 1.2 region. This is right there by the Galapagos in Ecuador. Temperatures where all that cold upwelling was occurring. You can see it peaked out about April 25th. Now temperatures on the rise, still cold though. 1.1 degree and 617 thousandths of a degree below normal. At least they're moving up in the right direction, but you got to be above half a degree. And this isn't the official El Nino monitoring region, but in general speaking, half a degree or higher is where you want to be. And in the official El Nino monitoring region, the Nino 3.4 region, the area on the equator south of California out to about the dateline, temperatures dropping 1 degree and 21 thousandths below normal. So right there, again, the half-degree line is the neutral line or neutral bias La Nina. You want to be a half degree or above. So we have miles to go from there. The models, though, have been pretty good at predicting this, and we'll get into that in a minute. The Southern Oscillation Index. So this is used, we've talked about down in the ocean, we've talked about at the ocean surface, and how's the atmosphere above the ocean responding to what's going on in the ocean, and the effects of Kelvin waves, the effects of the active and inactive phase of the MJO and La Nina. So difference in pressure between Tahiti and Darwin. Tahiti in the Pacific, Darwin in the Indian Ocean. It's the relative pressure difference. When pressure is lower in Tahiti, we can say, well, at a minimum, we're in the active phase of the MJO. Or if it's over a long enough period of time, that would suggest that we're in El Nino. But if pressure is lower in Tahiti, this index here would be negative, but it's been positive and pretty high, plus 31.44 a couple days ago. And just scanning down here through, it's been consistently in the upper teens to 20s for the past month. That's not good. That suggests the inactive phase of the MJO. The 30-day average, you can sort of get the noise out here at plus 19.76. We're at plus 20.01. That is the highest we've been in since the last La Nina last year. It peaked at, I think, plus 19, but it did it in like January. And here we are in late April, May, and it's finally waking up and, giving us a strong La Nina signal. The 90-day average averages all that out. 13.19, we were up at 13.69, I think that was the high, and just sort of looking down here, highest it's been in a while. So a very late manifestation of the La Nina signal all the way across the board here in April, the end of April, early May. Not sure what that means, but this number was as high or higher than what we had last year in the depths of our La Nina. This number, I think we got to plus 15 on the 90-day average, so still not quite as high here, but this certainly lags behind, so we'll give it about another couple of weeks, see where it goes. But clearly, all this suggests we're still in La Nina. The 30-day Southern Oscillation Index mapped out, you can see it right here. When you're below zero, you're in El Nino territory. When you're above zero, you're in La Nina territory. The last sign of anything that even smelled remotely like El Nino was January, the spring of 2020. Then in 2021, or the end of 2020, we peaked out at, there we go, about 20 and a half. Then this year, we thought we were going to avoid a peak like that because we were actually in a pretty good shape in January, but look at us now, as high or higher than we were a year ago. So this is your double dip La Nina. The question is, are we going for a triple dip? Quite rare, but maybe. Sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region, sea surface temperature anomalies. Right, so here we are, early May. Temperatures, according to this model, the CFS model, which seems to have a bead way better than any other model on what's really been going on, consistently been saying we're going to fall into this hole where temperatures go down about 1.25 below normal. And then maybe in July, starting to rise, sort of meandering around at about a degree below normal, which is fully La Nina territory. And then as we hit maybe early November, then the resolution begins and we start moving back into neutral territory. That's the raw data. PDF corrected basically says the same thing, going down about 1.25 degrees, rebounding to about 0.7, maybe even 0.65 degrees in July, but then sort of floundering around somewhere in the 0.7 degree range, again until November. And then as we get into January, finally, perhaps the end of La Nina. But let's be clear, if you're getting only to not even neutral, but 0.5 degree below normal in January, your winter's already toast. All right, the good news is there is a gale. over the dateline with decent seas, and forecast pushing over the dateline into the Gulf of Alaska. Swell is in the water from the previous little gale before that, supposed to arrive early week in Hawaii, midweek into California, and a day behind that, then a stronger swell from the current gale that's pushing over the dateline. So some swell for sure for Hawaii and the U.S. West Coast from the north. The problem with the U.S. West Coast is you saw it, a lot of high pressure, a lot of north winds, nowhere to hide from the wind. So probably it'll be pretty lost in chop. At least Hawaii will do something better. The flip side is down south. There has been a gale that a week ago, developed under New Zealand. Swell from that, hitting Tahiti, bound into Hawaii shortly, give it a couple of days, and then into California by much later in the work week, and continuing through the weekend with decent size, not huge, but certainly rideable. Protected spots will probably do pretty well, so at least there's something to look forward to there. Looking further out, North Pacific going to sleep. Southern Hemi going to take a little break, but then possibly, maybe it will try a little bit, or maybe we'll just sit there and get nothing. Sort of the hint is, if you can get some surf wherever it is and from whatever direction it is, go make the most of it while you can. Looking longer term, no clear-cut sign of the active phase of the MJO, no good support for storm development either north or south. La Nina clearly in control. That will likely put a damper on things going through this summer. No big surprise. We kind of knew that. We were hoping that La Nina would be fading, but all the data seems to suggest now that La Nina will continue at least into the early part of the fall. The models are split 50-50 on whether we go into a triple dip, a third year of La Nina, or maybe just sort of we eke out in a neutral pattern. But clearly you saw the best model there suggests that we aren't even approaching the death of La Nina from a water temperature perspective to January, which means it takes 2 to 3, if not 5 months after that for the jet stream and everything else to respond and the storm track to sort of readjust back to normal. So you're talking May or June. You're talking a year from now that maybe, just maybe, we could be starting to move back into a normal pattern. So not a lot of great news on this report, but we're hoping that La Nina doesn't fully do a third triple dip situation. All right, if you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Just hit the Stormsurf icon there in the lower right-hand corner. Comments, questions, always welcome. We try to respond. And that's kind of it. Go surfing, have fun, be safe, make the most of the waves you can get while you can get them. We'll do it again next week. Same time, same channel. Thanks for watching.